able to. Yeah, okay. All right, are you guys good on that? If the question asks, hey, when is the average rate of change always positive, you would just look at when the function is increasing. From there to there, from there to there. Are we good with that?
Yes.
Maris? All right, good deal. So here's another question. There's a couple questions like this. Okay, so this is kind of, I think this graph, or a graph similar to this, and this is a Unit 3, Lesson 3 question here. And it talks about inequalities. And this, when I give you this graph, the point of intersections are already given for you. So I have found these points of intersection, and these are all x values. They are given in the problem stem, and then you'll be asked some questions about it. And the first question as a review is, when the heck is f of x greater than g of x? So if you are just very careful and read the question correctly, all you want to know is where this graph right here is above this graph. Where is f above g? Well, f is above g when x is greater than f right here. All this area right here, when x is greater than f, then f is above g. All right? And then there's another question here as a review. When is h of x greater than g? So I want to know when h is greater than g. So that means where is the blue graph greater than the green graph right here? And we see that's going to happen right here. And that's going to happen between b and d. These are x values. And that's why the answer is between when x is greater than b and less than d. Okay, there's a couple questions. Just I had a couple. I watched a couple students take this quiz, and what they actually rewrote that problem on their notebook paper so they could decipher it better, if you will. So be careful with that problem. There's the same graph, I think, on two different questions. Okay, so are we questions on that? Are we good with those types of problems?
Yes.
Maris,
Yeah.
okay, good deal. So here's another tricky type of problem right here. Let me get all this stuff out of the way here. This is about end behavior. Okay? So I've got this polynomial that's in factored form. The leading coefficient is a, but I'm telling you right here, and you have to be careful, I want to know the end behavior, but I'm telling you that a is negative. So if I were going to multiply this out, I'm not going to, but if I were going to multiply that out, I would look at the first term, and we did a lot of that. And the first term is going to be the power function. And the first term is simply going to be this dude right here, ax cubed. Well, this is a cubic that's either going to start negative or end positive, or start positive and end negative. Well, this guy is going to start positive because a is less than 0. So if I put a big negative in here, negative cubed is negative times this negative is going to make this guy start positive, and it's going to end negative. So that's the end behavior. And if you look at your notes, and you're allowed to use your notes, if the leading coefficient is negative and the degree is odd, then it starts positive and ends negative. So this guy starts positive and ends negative. It looks like this guy's positive, but I'm telling you that he's not here. Okay, starts positive, ends negative. The other good question here, there's one like that, is the y-intercept positive or negative? Oh, so what I have to look at, if that guy wasn't in my way, I have to look at this last term. And what would that last term be? And you notice in your notes, if I find that, I'm just going to multiply these numbers right here. 2 times negative 3 is negative 6, times 4 is negative 24. But I can't forget to multiply it by that a there. So it's a times negative 24, and look here, a is negative. So negative times negative makes that guy positive. So the y-intercept is positive. And if I sketch this guy out, that would make any sense. That would make sense anyway, because I have the x-intercepts at negative 4. Right here, I have another x-intercept at negative 2, and I have an x-intercept at 3. So this guy is going to come here, down here and do this. And has to come up there to positive, and it's going to hit 3 and go on. So there's going to be a minimum and a maximum somewhere. Okay? So these problems are a little bit tricky because the reason why we're giving that problem is so that you just can't put something in your graphing calculator. You have to understand those notes about the end behavior and the power function. Oh, let me look at a couple other problems. There's a couple of those A problems. Here's a problem. Another problem. Example type problem. So the question is, what happens? And there was a activity about this. What happens at x equals negative 2? So can either of you tell me what happens at x equals negative 2? What happens to the graph of f of x? What happens to f of x at x equals negative 2? Can either of you tell me? Anybody? Maris? You know, dear. Brendan?
Not sure.
Well, if you have one of the factors, first of all, there's x-intercepts. The x-intercepts are 3, because that's where it's 0, negative 2, and 1. The power function of this guy is going to be, if I were to multiply this out, this would be x squared times x times x. So it's going to be x to the 4th, but it's going to be a. And we'll just right away, we'll make it easy, we'll just let a be positive. So this guy, power function, is going to be ax to the 4th. So it's going to start positive and end positive. So if I looked at the graph here, it's going to start positive. It has to hit negative 2. It has to hit 1, and it has to hit 3. This is 1, this is 3, this is negative 2. And if I looked at the y-intercept over here, so this is going to be 4, negative is positive. It's going to be 4 times 3, which is 12. It's going to be 12a, but a is positive, so it's going to have to be up here, the y-intercept. And look what has to happen. And these are the only x-intercepts. So it has to come back in here. It can't cross because it has to hit this positive y, and then it comes down here. And it starts positive and ends positive. And what happens to the graph, whenever you have a factor that's to an even power, the graph bounces at that value. So the graph comes down here and bounces at -2, goes up here max, and come down here min. So you have to recognize the x-intercepts, you have to recognize the end behavior, and then the y-intercept. So that is a question. And then there's a question. There's a couple easy questions if you have your notes. I'm going to list some functions. You tell me if they're polynomials or not. All right, are these guys polynomials? Number one?
The first one is.
Yep.
The other two aren't.
No.
They are not. Good deal. This one isn't because you have this guy right here, the square root. That's x to the 1/2. Awesome. And why isn't this one, Brandon?
The negative.
Because of the -1. Right, to the power of -1. I tell you, I don't, let me do a very simple y-intercept. Here's a very simple one. Y-intercept. There's a very simple y-intercept. Do you know, Maris?
I'm feeling kind of sick, and if I don't answer, I'm just like not feeling well right now.
That's all right, honey. Brandon, do you know the y-intercept?
So would it be like 1, -1, -3, and 2?
Well, those are the x-intercepts. So the x-intercepts are going to be 1, 0,
Yeah.
-1, 0, and negative. There's a question like that, -3, 0, and 2, 0. The y-intercept happens when you put 0 in for x. It would be 6, because it would be -1 times. It would be -1 times 1 times 3 times -2. Negative makes it positive, so it's simply 2 times 3 is 6. So the y-intercept there is 6. There's a couple easy questions like that. Other than, there's a couple about, properties. You're allowed to use your notes. It's not going to be timed. So I would just make sure you have your notes handy. There's some tough little questions. So are we ready to go, or are there more questions? Or you want to give it a whirl?
I think we're good.
Maris, you good?
Yeah.
All right. Well, I will post this for you two guys, and then I'm actually going to post this video as well.